Alright, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Shauqie bin Ahmad Fazil. My metric number is 11DKA20F1044. So today I would like to present to you about the non-uniform for open flow channel. So first of all, this is assignment 2 from hydraulic assessment. Question 1. The question is, Parit Jaron in Tangka experienced bank corrosion. Therefore, a drainage need to be designed to overcome this problem. As an engineer, you are required to calculate the expected discharge for the channel. Below is the data from this side. So we are given, first of all, the surface of the channel with wide, which is D is 3m wide, and then the side slope 1, depth D, which is 1m, the bed slope 1 in 1006, and type of channel, which is made of concrete. So based on this information given, we have to conclude and calculate what the expected discharge for the channel. So to identify the what kind of solution that the question need, we need to identify what is the many needs, the equation of the many. So first of all, we must identify all the needs of many equation, which we need the Q flow rate, and for the many coefficient, E flow rate, flow area, R hydraulic radius, and I for the channel slope. So based on the data given, so first of all, we have to identify the flow rate, which is Q. Q equal to A times V, which is the diameter and the area. So A equal to dy plus zxy2. Based on data given, we can conclude that 3 times 1 plus 1 times 1 square, 1 power of 2. So we can get the answer of 4. After that, we have to identify the V. So what we need to do, we have to identify from the other equation, which is P. So using P, we use the equation B equal B2 plus 2y square root of 1 plus z2 power of 2. And so when we put all the equation down, so we can get the 5.828 for the answer of P. Alright, okay, and then we use the equation of R. So R equal to A divided by P. So based on two answers that we can get 4 divided by 5.828, we can get 0.686. So we have all the needs for the main equation. We put all together in the equation and we can get 6.48 meter cube per second. That is for solution of question 1. Okay, now we can proceed to the next question, which is question 2. So for the starter, we have the data of the drainage. First type of channel, rectangular, wide with 6 meter, discharge of 8.5 meter cube per second. Type of surface of the channel equal to earth of ordinary surface. So basically there are no concrete or anything, it's just surface of the earth, which is the soil. Okay, then the question 2, as the hydraulic consultant, calculate first critical depth, which is YC, critical velocity VC, critical slope S, and the last one is minimum specific gravity min. So with the data given, we have to put it aside and discuss how we can get the first solution for the critical depth. Okay, now how the solution of the critical depth YC. So the equation of the YC is Q power of 2 divided by G gravity, and in equation of 1 per 3 power of 1 per 3. So we have all the data given, which is 1.417. Okay, we power of 2 divided by the value of gravity, which is 9.81. So it's in box, and power of 1 per 3. So we can get the answers of 0.589 meters. Alright, after we get the answers of 0.589 meter, now we can solve the second question, which is critical velocity, VC. So to find the VC, we must divide Q divide by YC, which is the answer of the question 1. So 1.417 we divide by 0.8589. So we can get the answer 2.406 meter per second. Right, now we're gonna settle for the equation number 3, which is critical slope S. So basically, to get the answers, we must solve the equation of Q, which is contain 1 over 9 over n times A R power of 2 per 3 and I power of 1 per 2. So basically, to get all the input of the equation, you must solve certain equations such Q, A, R and P. So basically, first we started with the Q, which is A times V, which is area times to the depth. So basically, to get A, we must divide Q per V. So we take from the data given, which is 8.5 divided by 2.406, and we get 3.533 meters square. So from the answer given, now we can put it aside and take the equation of P, which is P equal to B plus 2y. So the depth y. Okay, so we take B from the data given, which is 6 plus 2 times 0.589. So we can get the answers of 7.178 meters. Okay, after answered both of the answers, now we have to solve the equation of R, which is A divided by P. So take the answers from 3.533 meters square divided by 7.178 answers. Then we can get the answers of 0.492 meters. Okay, now we got all the element of the Q and put all together in the equation. So we can get the answers of I equal to 0.31. Now, for the last of the question, which is minimum specific gravity, E mean. Now, to get the E, use the formula of E equal to y plus 2v v power of 2 divided by 2g, which is gravity. So put all the element, which is 0.589 plus 2.405 power of 2 divided by 2 times 9.81, the value of the gravity. Now we can get the answer of 0.883 meter of minimum specific gravity. So after all the questions, we know that all the equation are getting to one from another. So basically, the conclusion is to unable to answer all the question, you must understand every step and what we need to find. So based on that, we can get all the answers with only one equation and understandable of the equation itself. So it really helps, and most importantly, to use your calculators wisely, unless you have used the formula right but the answer is wrong because of your own self faults. So that's all from me. Thank you. Assalamualaikum.